empirical formula. What it is? It is simplest whole number ratio of atoms in a compound. How it differs from molecular formula? Molecular formula is the actual number of atoms in a compound. Molecular formula represent in its formula the actual number of atoms in the compound. In empirical formula, we represent the atoms in a compound in its simplest form. Okay, so let's take an example. Hydrogen peroxide. From the molecular formula, we can say that hydrogen and oxygen are present in the ratio 2:2. But this ratio can be divided by a factor 2. We can represent this factor as n, which is 2. And by dividing this ratio by 2, we are getting the simplest ratio. What is the simplest ratio? Here 1:1. Empirical formula says that it is the simplest ratio, right? This is not the simplest ratio. 1:1 is the simplest ratio. Therefore, the hydrogen and oxygen atoms are present in the ratio 1:1 in its empirical formula. Therefore, empirical formula for hydrogen peroxide is HO. Now, from seeing molecular formula and empirical formula, can't we say that molecular formula is a multiple of hydrogen of empirical formula of this HNO by a factor 2, right? Thus, I can write molecular formula as a multiple of empirical formula by a factor n, right? Now let's learn how to calculate empirical formula, how to find out. Take this example where the question is saying that a substance on analysis gave the following percentage composition, that the substance has sodium in 43.4%, carbon in 11.3%, oxygen in 45.3%, and the question is asking us to calculate the empirical formula, and it has also given us the atomic masses. So guys, the first step to calculate empirical formula is to find out relative number of moles. How to find out relative number of moles? Relative number of moles is equals to आपकी percentage composition upon atomic mass of the atom, right? So relative mole of sodium will be sodium is 43.4 upon 23. This will come out to be 1.89. Now let's find out relative number of moles of carbon atom. The percentage composition of carbon atom in the question is 11.3, and we are dividing it by atomic mass of carbon, which is 0.94. Now relative number of moles of oxygen atom is the percentage composition of oxygen, which is 45.3, divided by its atomic mass, which is 16, which is equals to 2.83. Now we'll move to the second. Now in the second step, we will calculate simple ratio. How we will calculate simple ratio? Simple ratio will of each atom will be calculated by dividing relative number of moles of that atom which we calculated in step 1 by the least value obtained in step 1. See, in step 1 we calculated the relative number of moles, right? And among 3 the smallest value is relative number of moles of carbon in this question, which is 0.94. See, 1.89, 0.94 and 2.83. 0.94 is the smallest. So we will divide each of the relative number of moles with the smallest value, which is 0.94. 1.89 upon 0.94, 0.94 divided by 0.94, 2.83 divided by 0.94. Now, as I explained, simplest ratio of each atom will be equal to the relative number of mole divided by the least value, which was 0.94. So 1.88 by 0.94 will give the simplest ratio for sodium, which is equal to 2. Simplest ratio of carbon, which is 0.94 divided by 0.94 is 1. Simplest ratio of oxygen, which is equals to 2.83 upon 0.94. Or to simplify our calculation, we can mention it 2.82 divided by 0.94. A 0.01 value difference will not make any significant difference. So the answer here is 3. Therefore, from these simple ratio, we can say that sodium is to carbon is to oxygen is proportionate to 2:1:3, where sodium corresponds to 2, carbon corresponds to 1 and oxygen corresponds to 3, right? And also we can say that 2:1:3 does not have any common factor, right? 2:1:3, as it is evident that it does not have any common factor. So this is also the simplest ratio. Thus we can write the formula as sodium corresponding to 2, therefore Na2, carbon corresponding to 1, therefore C, oxygen corresponding to 3, O3. Thus the empirical formula is Na2CO3. A point to be noted here is, if the simple ratio in any one of these was obtained in a decimal point, then we will round it off to obtain the simplest ratio. Why? Because in the empirical formula definition, I mentioned it that empirical formula is the simplest whole number ratio. So it has to be the simplest ratio, as well as the ratio should be in whole number and not in decimal.